Hello, and welcome to today's lesson on Logic and Reasoning Lesson 2. So today what we're going to do is we're going to take that pattern recognition that we noticed and worked with in Lesson 1, and we're going to be able to build formulas that will allow us to find any term of the sequence. If you think back to that last lesson, we were having you always find the next term, so all you had to do is continue the process. So in this situation, what we're doing is looking for that nth term, and think about a situation. If we wanted you to find the 41st term, how many times you would have to add or subtract or multiply that value. If we wanted you to find the 110th term, okay, it just takes too long. So what we're going to do is we're going to build some functions, some equations that will help us find those terms. Now, the first thing that we want to do is we want to identify patterns, build out the table, use the table to help us come up with the equation. Now, what happens if you notice, I'm listing the zero term in this table. The zero term will help us, one, because we have the formula, so we can plug in to the formula and solve, but it will also help us see how the formula is built. So when I plug in 0, I get a minus 5. If I plug in a 4, 4 minus 5 is negative 1. And we keep going. We plug in a 5, we plug in a 6, we plug in a 7, we plug in an 8, and we kind of fill out the table. Same thing here for B. We plug in a 0, we end up with a negative 3, and then we keep working through. We plug in a 4, we get 13. Plug in a 5, we get 17, 21, 25, 29. Okay, so we're following the pattern by plugging the numbers into the equation and solving. Same thing on the bottom. Negative 2 times 0 is 0. 0 plus 5 is 5. And then we keep plugging in our values. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. Okay, so we keep working through this process, and then the table fills itself out as we work our way through. So now, if we look at this table, we want to notice some similarities. Okay, hopefully the number one similarity you saw is this 0 term in the table is the addition or subtraction at the end of the function. So here it's a plus 5, here it's a minus 3, here it's a minus 5. Okay, so that's the one thing that we noticed. Now, the second thing that we can notice if we look at our pattern is what's happening with the values. In this first table, everything is a plus 1 going from the next term, or from first term to the next. In our second table, everything is a plus 4 as we increase. In the third table, everything is a minus 2 to get to the next term. So if you look at what we have, what's being added or subtracted, okay, that's what we call our constant value, because this is a linear equation. It's a constant addition, constant subtraction. So our constant values go in front of the n, and then the starting value of the table gets tacked on, and that builds the equation. We can find any value we're looking for then at that point. So let's try this with one addition problem, one subtraction problem, so we can see what's happening. So we'll give you the list of values, 1, 2, 3, 4, so that's the term. So term 1 is 2. Term 2 is minus 3, and what we can see in this situation is we're subtracting 5 every time. So if we wanted to fill out the table, we could. We could just continue to subtract 5. And if I can subtract 5 the right direction there, it would be okay. Okay, but now what we want to do is we want to find out what is the 0 term. because we know now that the minus 5 is building that leading value, and I'm going to make this a little bit bigger here for our function. We're subtracting 5 every time, every term, so we know that piece, and then we can either back up, so in this case add 5 to get our starting value to build the equation, or the second option that you have is we know that if we are subtracting 5 every time, we know that if we plug in a 1, we get an answer of 2. Okay, now, this isn't equal to each other, so we need some constant value. We'll just call it b, but we know that negative 5 plus b equals 2, and if we add to both sides, we find out that b equals 7. So that's an additional way to get the full finished equation. You can either back up with the pattern and add 5 to get to your 0 term to help you get there, or what you can do as soon as you know what your addition subtraction value is, start to build the function, and always test your function with points. Test a point in the equation. Plug in a 4 and make sure that when you plug 4 into your equation that you're getting a negative 13. Okay, you can guarantee that your equation is correct if you're willing to test values to test points. Okay, so now we've got a situation here where our values are growing. From 5 to 17, they're going up 12, up 12. So if we wanted to, of course, we could fill out the rest of the pattern. So we would add 12 and we would get to 41. We would add 12, and we could continue going. Okay, but we want to build the equation, because what I want to do here is I want to find the 120th term. Okay, so I want to find term 120. We couldn't do that by continuing out this process. So what we know is we know that we are adding 12 every time. That becomes our multiplier, because we're doing that 12 any number of times. And now what we just need to finish out this function or this rule is we need that starting value. So one thing we could do is we could subtract 12 to get to the 0 term. So 5 minus 12 is a negative 7, okay, and that gives us our function as well. Or remember the other option that we have. We know our multiplier is 12, we know our first term is 1, we know the answer that we get is 5, and we know right now that 12 does not equal 5. Okay, we're trying to find that b value. So 12 plus what equals 5? And if we subtract 12 from both sides, we find out that it is a negative 7. Okay, and that gives us the function that we're looking for. So if we're looking for our n of 120, we would just do 12 times 120 minus 7, and that would give us the answer for the 120th term. So 12 times 120, enter, minus 7, enter, and we get our 120th term, which is 1433. Okay, now, this does work with any number sequence we have, but it can also work with situations or ideas. So here we're talking about the number of sides and the number of triangles that we can build from it. So when we have a 3-sided shape, 1, 2, 3, we can build one triangle. When we have a 4-sided shape, we can put in the possible diagonal, okay, from just one vertex of the situation. Okay, so now we have 2 triangles. Okay, now we have a 5-sided shape, 1, 2. Okay, so we're just drawing all the diagonals we can from a specific point. We've got 1, 2, 3 triangles for a 5-sided shape. six-sided shape, we can see that we've got 4. So now, once again, we've built the function based on number of sides. Okay, so a three-sided shape gives us one triangle, four-sided shape, five-sided shape. Okay, so we have our situation. Now what we do is we look at the scenario, what's happening from one to the other. Okay, so we have a plus 1, a plus 1, a plus 1. So we know that this is a plus 1 in the beginning of our function. Now the hard part here is we could back up to get to 0, but understand that we would have to go 3, 2, 1, 0 to get to that starting value. Okay, so what we could do is we could back up and we would go 0, negative 1, negative 2. Okay, so we have that situation. So you can always back up to find what you're looking for. Okay, now we can also just plug in what we're given. We know that the function, when we plug in 3, is equal to 1. So if I do 1 times 3 minus b, or plus or minus, we don't know what it is, we know that that has to equal 1. So it has to be 3 plus b equals 1, b equals negative 2. Okay, so remember, there's the two ways of getting to that value. You can either go in the opposite direction for your pattern, or once you know what your addition is every term, plug that in for n and solve for that b value, that second value for your starting point. Now, always test your function just to make sure that it's working properly before you answer the final question. Okay, always test it with some other value. So we're going to plug 5 into our function. 1 times 5 minus 2 equals 3. Okay, I've checked and I've checked. So now when I want to find f of 35, I know that this function is going to work properly. I'm plugging in 35 for n. So 35 minus 2 gives us 33 triangles. Okay, one more example to finish up here. You know, just looking at the different scenarios that we can do, the different patterns we can be looking for in a situation. What we're doing is we're building basically house colonies based on matchsticks. Okay, and our first figure took 5 matchsticks, and there's 5 around the perimeter. 1, 2, 3, 4, 5. Okay, our second image, okay, 2 houses connected to each other. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 around the perimeter, but there's a 9th in the middle, so that's why there's the difference between the two. Okay, we continue on for our third situation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 around the outside, and then we've got 12 and 13 for the entire shape. Okay, so the number of matchsticks is going to be one equation based on the figure number, and the number of matchsticks in the perimeter is going to be a different equation. So now we have our basic pattern. So f of 3 is 13. Okay, hopefully we can notice the pattern. We don't have to go back. We've got a plus 4, a plus 4. So we're going to have a plus 4, continue on. 17, 21, 25. Okay, so now since we know that we're adding 4 every time, we know our multiplier by n. Okay, we can back up in the process to get our 0 term. So we have to undo the adding of 4, and we would have to do a minus 4 to get back here. Okay, so that is, in most cases, your quickest way to get there. Okay, remember to always test and make sure that your equation is working properly in that situation. Okay, and I almost made a pretty common mistake. Okay, it's a +1 in that scenario when we're backing up 4. Okay, and the reason why I knew that I made a mistake is I was looking at and testing this value. So I was plugging a 3 in for n and noticing that I was not getting 13 for an answer. I knew something was wrong. I looked back at what I did, found that simple mistake. Okay, I'd like to say I did that on purpose, but I didn't. You know, it's a good life lesson. Teachers make mistakes as well. So if I want to find the 200th function or 200th figure here, it's going to be 4 times 200, which is 800, plus 801 matchsticks to make that figure. And then we would do the same thing in the perimeter. We can see the perimeter is a +3, +3. So we would continue on for all of those. So we've got 11 +3, +3, +3. So we're following the pattern. Since we know it's a +3, we know our multiplier in front of the n. And then what we have to do is we have to subtract 3 to work backwards from the first term to the 0 term. And that gets us a 2 in that situation. Okay, no mistake there, right? +2. Test a value to make sure that it works. Let's plug in a 2. 2 times 3 is 6. 6 plus 2 is 8. We know it works perfectly. So now we can finish out by plugging into our function. F of 200 means that we're plugging in 200 in for n, and then we're solving. So we have 600 plus 2, or 602 matchsticks in the perimeter. Okay, that concludes our lesson for today, building functions for our conjectured numbered patterns. Thank you and have a good day.